All right, so today, first, we want to start off with a question off of worksheet 5. You guys were assigned 7, 8, and 9 on worksheet 5. Ironically, it was the same question that they asked me last hour, so let me just get rid of that ink real quick, and we'll do it again. All right, so we have this question on worksheet 5B, number 7. They're planning a wedding reception, this caterer, and they have to create a nut mixture that has 25% peanuts, and it has to be 20 pounds, okay? So they're going to create that by mixing 2 different varieties they already have to create what they want. So I always start these problems by kind of like literally thinking about mixing 2 things together. This is on worksheet 5B. So you have a 40% mixture and a 10% mixture, and you want to create a 25% mixture. And then how much is in each bucket? Like, I don't really know that. The only thing I do know for sure is that the final product has to have 20 pounds in it. So it would not be wrong of you to call this X and Y and set up a 2-variable system. So the first equation is going to involve the concentration or the percentage of peanuts in each of these. So like this would be 40% times X plus 10% times Y, and then 25% times 20 would be a 5. But the other equation that we know is that X plus Y has to equal 20. So this would be a great system for you to solve through whatever method you want. However, which I know you guys usually look at these and you're like, I love elimination, I'm going to do elimination. But you have to kind of think about being flexible with your math. If this was a no calculator question on an SAT test, I don't think elimination is the best choice. I think actually substitution is the best choice. And furthermore, I think you could jump straight to the substitution if you do a little bit of thinking, guys. Instead of calling this Y, what if I called it 20 minus X? Because think of this. If I have like 5 pounds in this mixture, that means this one has to add up to 20 with it, right? So it's got to be 15, and you found that by taking 20 minus 5. So if you wanted to set up your equation like 0.4x plus 0.1 times 20 minus x equals 5, you jump straight to the substitution part of the system, which would have been your next step here. I only show you that because I know you guys love shortcuts. So, turns out this is all a moot point because today we're going to introduce you to how to use a matrix to solve systems of equations of any variety, and you're going to love it. And if you ever have the chance to solve a system with a matrix, you're probably going to go, yeah, I think I want to do that, because it doesn't require any work, or little work, I should say. It requires a little reformation of your equations, and then it requires interpretation of the matrix. Other than that, not a lot of brain power. Today's going to be a good day. All right, you ready? Was that the only homework question? What else you got, Scott? Oh, that was it? Okay. I'm going to let you guys solve that one, obviously. It's not done. You got to keep going. All right, could you please look at worksheet 8? This is where our notes go. And I don't know if you've ever noticed this, but the elder generations, you know, your parents, aunts, uncles, grandparents even, probably have some negative feelings about their math experience in high school in particular. And this is one of the reasons why. So as technology progressed, you know, things got easier, and they look at what you guys are doing and they're like, I didn't have those fancy things when I was a kid. I had to do all this by hand. Today is a good example of technology really streamlining our lives. When we used to have to solve these questions by hand, and this doesn't go too far back into history, guys. Like, I'm not that old, but I still had to solve these by hand, okay? They're not fun. They're not fun at all. In fact, every problem could take you like 30 minutes. And if you're not careful, which I'm not, you find out in the middle of it you made a mistake and you got to start all over again. So let's talk about some things that we do have to know for our upcoming test. By the way, this week we got a little bit of stuff to finish. We're done learning on Wednesday, so pretty much I can just go home and stay there. So you're on your own after that. You got a review on Thursday for this Summit of 11. You have Summit of 11 on Friday. And then next week begins your fun of post-testing, which is, you should have a lot of post-tests throughout your courses. I get the impression some of your teachers haven't warned you about next week yet. Well, the final exam schedule starts December 17th, but that's not, you guys have more than that. You guys remember how this works? Like, there's post-tests too that usually teachers give the week before. Yeah, that's right. 18, 19, 20, yeah.
Other teachers do post-tests?
Yeah. A lot of them do.
Why?
So whiny. Okay, so today we're going to talk about, I think you guys will enjoy today, except for Daniel. He's very crabby right now. We're going to take, essentially we're taking 3 variable systems, and really any type of system. We're going to change it into an augmented matrix. Technically, we're supposed to use Gaussian elimination or row operations, which we're not going to do by hand, because I'm going to show you what it is, and it stinks. And we're going to make our calculator cheat for us. So our job is to use our technology, but know how to interpret the answer from the technology. That's going to be our task for today. So first thing we got to get under our belt is, what does it mean to be an augmented matrix? So I can give you a system of any variety. This particular one is a 3-variable, 3-equation system. Notice how they've lined everything up perfectly. So the first column is all your x's, and the second column is all your y's, and the third column is all your z's. And then the fourth column is all your solutions. So everything's set up perfectly. Then they're going to transfer it to what's called an augmented matrix. So the first thing you'll notice is they put little matrix brackets around it. And they pull off just the coefficients to everything. And they put a line that separates the coefficients from the solutions. What you'll see your teacher do often is just like a little dashed line that separates the body of the system from the solution of the system. You really don't have to have anything in your matrix to separate them. It's just nice and visually appealing to put that line there. That's called an augmented matrix. So that's one of the skills I will require you guys to do. Take this system, write it as an augmented matrix. Now, a little more vocab. If I peel off just the coefficients and don't put the system solutions there, you have what's called a coefficient matrix. That'll come up tomorrow a little bit, but for today it doesn't really have anything to do with us. All right, this is why parents are so crabby. Row operations. Now they've used the title elementary row operations, indicating that it's so simple. Elementary does not necessarily mean simple in math. Tedious is probably a better adjective for it. But they basically make you take each row of the matrix, multiply it by something, add it to another row, because your goal is to get this matrix to look like this. You want your final matrix to look like 1, 0, 0, and then some sort of a solution. 0, 1, 0, and some sort of a solution. And 0, 0, 1, and some form of a solution. This is called row-reduced echelon form. So how does one do that by hand? And the answer is actually not easily. And it's not elementary at all. The math is elementary, but the process, it's like those of you who like Rubik's Cubes, this is a mathematical Rubik's Cube. So you play with it until you get it to work out. It's not fun. We're going to do this on the calculator. I'm going to show you this in a minute, but I think I have a good visual for row. Oh, no, I don't. All right. If you're very interested in what they wanted you to do, they take the matrix, and they basically do some, it looks like kind of like elimination. So what you can do, like let's say I want to have an operation done where I'm trying to get this guy to be a 0. Well, I could take this row and multiply it by -2 and add it to this row. But here's the catch. You take the answer to what you're about to get and you put it wherever you want it. So I just put that answer in row 2 and I walk away from that. And I've made one fix to that Rubik's Cube puzzle. I've created a 0 right there at the beginning. But I've messed up a lot of other things. So then I go and I fix the next one. And then I go fix the next one. And then I go fix the next one. And it takes you I'm not kidding, like some of these take 30 minutes. Especially if you're prone to error like your math teacher. So then, my math teacher spilled the beans because I'm really not that old, I swear. We had TI-83s back in my day too. So they're like, hey, did you know your calculator can do this in 4 seconds? And we were like, what? So that's what we're going to do. Because it's an antiquated process to ask you guys to do row-reduced echelon, to do row operations by hand. It's kind of fun if you like puzzles, but it's so antiquated and not useful anymore that we just really don't need to teach you right now. The next time you see this would be if you take a college algebra class, perhaps you will see one in college, or if you take what's called a linear algebra or any computer programming classes, you might see these matrix operations a little more closely. But for most people, they don't see matrices too much in their lives unless they go into computer science. Matrices, however, are incredibly awesome and used in real life. Hopefully this week I have some time to show you a TED Talk on a woman who will give you guys some concrete examples of how matrices are used, because they are very, very amazing. All right, here's what's going to happen. Our calculator is going to do some magic for you. But first thing you have to do is to know how to enter this into your calculator. So you're going to take your augmented matrix and you're going to enter it into your matrix menu. So go to your calculator. Which mine is, oops, I shut mine down. Let me try that again. Oh, no, I didn't. There we are. All right, do you find the matrix menu anywhere? It's hidden. It's in the blue ink. It's right above the inverse key. So if you go second inverse, it'll take you to the matrix menu. So the matrix menu has 3 sub-menus. The first sub-menu is just the names of the matrices. I have an old matrix from last hour still entered. That's why you see some dimensions on my matrix A. It's very likely yours is just empty. There's nothing. Math is where we can do some calculations with our matrices. We'll come back to this in a minute. And the edit menu is where you actually edit and change the matrix itself. So in the edit menu, I need you guys to open up a matrix of your choice. I always go to matrix A for Abruzzo. It's the first one, that's why I really go to it. And then I have a matrix A right now. If you don't have a matrix A, or if you have other dimensions here besides 3 and 4, you need to change this. So this menu is a series of overtypes. So to move from spot to spot, you can just type and hit enter. So 3, enter 4 is how we're going to change the dimensions. If you didn't already have those dimensions, your calculator would have adjusted them. Now, the reason I chose 3 by 4, look at that augmented matrix. Do you see 3 rows and 4 columns in it? That's why I went with 3 by 4. So now you enter all of the coefficients for that matrix. And actually, I think this is the right one. Yay. So I don't have to type, but y'all should be typing. Is this the right matrix? Sure is. All right, I'll pause while you guys all type. So the typing you may have found a little tedious, and that is probably the hardest part of today besides interpretation, but that's entering a matrix into matrix A or wherever you entered it. Cool. All right, go back to the matrix menu. And this time we're going to perform some math with that matrix. So go over to the math menu. And there's a lot of options that we aren't even going to discuss, but the one we're going to use today is the command that does RREF, which stands for row reduced echelon form. It is letter B down your list. Unless you have an older one, it might be something else. Yes, make sure it's the one with 2 R's in it. REF is different than RREF. All right, so choose RREF and then tell him which matrix you would like it to perform RREF on, and that would be matrix A. So the way you pull up a matrix is you go back to the matrix menu and you just choose matrix A in the names category.
I have no idea what just happened.
Oh, guys, you see what I did?
No.
I was still in my matrix.
Okay.
I never
so I
exited my
was doing it
matrix.
right.
You were. It was my bad. All right, hold on. Quit, clear, stop, quit. What's 1 supposed to be? Just a 1? Okay. What I should have done, thank you, Daniel, I should have quit out of this matrix. Because I was still in the edit mode of my matrix, and maybe you guys were too, but you're probably smarter than me and got out. Okay, now I'm going to go back to my matrix menu. I'm going to pull up the command to perform RREF and tell it to do it on matrix A. So back to the matrix menu and just choose in the names category matrix A, or wherever you put your matrix. Hit enter, and it produces what's called a row reduced echelon form solutions matrix. So what I want you to do, and I know there's not a ton of room because we're skipping a whole bunch of stuff on this front. Basically, guys, I'm not going to have you do any of that row operation stuff at the bottom or anything off to in the middle even. So, oops, back up, Abruzzo. So when you did RREF on the calculator, it produced this. 1, 0, 0, negative 1. 0, 1, 0, 1. Kind of. True and it's not binary, but like the concept of like 0 being a false and 1 being a true is Boolean algebra, but it's not quite that either. Boolean algebra, right? Okay, so here's what you have, guys. This is your job to now interpret this. This row right here, if I translate it and put the x's and y's and z's back in the formula, it says 1x, because remember x was in the first column. This says x equals negative 1. And then this row, what does that say? y equals 1. Now what does this row say? Z equals 2. So on your formula, or on your worksheet here, where they ask you to write, oh, they didn't ask me to write anything, I guess. Do you see it kind of in the middle of the page? It says, what are your solutions? Well, boom, there they are, guys. X is -1, Y is 1, and Z is 2. Now, the other thing that we need to be aware of is your math teacher is always going to want you to write these as ordered triples. So you just write them in alphabetical order, X, Y, and Z. So I know the typing took a little minute, the getting used to the keystrokes took a minute, but the actual calculation component and interpretation of it took like 5 seconds. So that's much faster than the by hand part for sure.
Wait, and then, so if you plug those numbers back into the equations up front, you get the solution.
Well, like if you plug them into the top equation, you'd get -1 equals -1. You just get a statement that says I equal myself, because this is the solution to the system. -1, 1, and 2. Okay. If you plug a solution into its equation, you just get a true statement back. Like if it was a line and you plugged in the answer is 7, you'd get 7 equals 7. Yeah. You'd be like, ooh, cool. All right. Let's take a look at, let's flip to the back. So, row-reduced echelon form. The one we just saw was a really cool system that came up with a unique solution, an ordered triple. And that is typical for like real-life problems, because there's usually one solution to those boring real-life problems we get. So at the top here, some vocab for you to write down. The RREF command stands for row-reduced echelon form. And the main idea for row-reduced echelon form is that you're trying to get ones along the diagonals, and ideally you'd like to get zeros everywhere else. But we're going to find out in a minute that not every system has a unique solution. And you kind of already know this. Let me bring you back for a minute. When you were doing system of equations back in algebra, and you ended up with this, what happens? So you did your math and you tried to do elimination and you end up with 0 plus 0 equals 7. What did your teacher tell you the solution was in this case? That there is no solution. And the technical name for this system is that it's an inconsistent system. There is no solution. So I can't have any sort of a relationship between the variables. But what if the math was similar, but it came out to this? Now what does your solution say? 0 plus 0 equals 0. Well, that's a true statement. 0 does equal 0, but it's not like a helpful statement. It doesn't tell you a unique solution. So this was a case where you had infinitely many solutions. And technically the name for this system is a dependent system. So you could always create a relationship for one variable based on the other variable's number. So like for instance, if I knew x was 2, I could find a value for y every single time. But the value for y is dependent on whatever I plug in for x. There's no unique solution. So today, we're going to talk about how to interpret various augmented matrix solutions that could come out of our calculator. So this is a question that shows up on your test on Friday. This question shows up on your post-test next week as well. Oh, speaking of post-tests, I think we have decided to adjust our schedule for next week. Originally, we were planning on Wednesday and Friday for your post-test, but we have this vision of like a bunch of people giving a post-test on Friday. We don't want you to have to take a gazillion tests on Friday. So I think we're going to shuffle our post-tests to Tuesday, Thursday next week. Does that do bad things to you, Jacob? On Wednesday, we're going to review for the Thursday part. So like on Monday, we review for part 1. We take part 1 on Tuesday. On Wednesday, we review for part 2, and we take part 2 on Thursday. Okay? What, does that do bad things for you? What'd that mess with?
He's going to be sick that day.
What?
Oh, yeah, I am going to be sick that day. I got a physics presentation, and I already told her that I feel like I'm coming down with something, so I won't be able to do it on Monday.
Oh, sorry, Rufa.
That's true.
Okay, so let's look at this first augmented matrix solution. interpret this first line for me, guys. And let's just always assume they're using X, Y, Z, like whatever in the same order for these. What does this say? X equals 19. What does this next line say? Very good. Z equals negative 20. So this is a case where we have a unique solution. Your teacher would love for you guys to write them as ordered triples in this case. So this would be 19, comma, 4, comma, negative 20. And that's a typical solution that we're used to seeing in algebra. Huh. You're looking at the next one and you look a little confused, right? Okay, well, let's just write down what we see. So this top line says X minus Z equals 0. That's interesting. Let's just work with it for a minute. Let's look at this next one. Y plus 2Z equals 0. Okay, also interesting. And then I get this statement. 0 equals 1. And I go, her? This is just no solution. So that's very typical of what you saw in algebra. You got some bogus statement that makes 0 sense. Like you can't have 0 of something equaling a 1. Just not going to work. Go ahead, Daniel. Try it. All right, this next one. This is the more difficult one, guys. So hang with me. Just like you did on the previous question. Can you translate this line for me? Very nice. X minus 6Z equals 4. Very good. Y plus 2Z equals negative 3. And then at first I was like, ooh, it's going to be one of those no solutions. And then I realized what that says. It says 0 equals 0, which is actually true. So that doesn't mean this is a no solution. This is one of those infinitely many solutions. But we got to do better than this because we're pre-calc. You can actually give me an ordered triple. Ready for this? Go ahead and write yourself a large and in-charge ordered triple. Leave yourself a little bit of room. I wonder if you guys could do some rearranging and give me some formulas that will help me find X and Y and Z if I'm ever given the case of plugging in a number. Let's start with X. Could you rearrange that blue equation so it says X all by itself? Yeah, I like that. 4 plus 6Z. 6Z plus 4, either order. There's your X. So do something similar for the Y. What could Y equal? Negative 3, but then you have to subtract the 2Z. Very good. And then I'm scrambling because I'm like, wait, what about Z? How about Z? Can we just call it Z? So here's what you have here, guys. You have a 3-variable system solution that has some formulas for X, some formula for Y, and Z is just Z. So this is a dependent system. Depending on what you plug in for Z, you're going to get different values for X and Y. But they're all going to be solutions. So if you decide you want to find out the solution when Z equals 7, you plug in a 7 for all your Z's, and boom, you got your ordered triple. That is a solution. There's just so many of them that you can't come up with just a single unique solution. We didn't usually have you do that in algebra, because that like really boggled algebra kids' minds. But we could have had you come up with a variety of solutions that worked. Like come up with at least 4 solutions. So you'd pick your 4 favorite numbers and you plug them in for X or whatever you had, and you'd find your 4 mysterious solutions. All right, so that was fun. Let's take a look at some examples. So skip number 1, let's look at number 2. I need you guys to start typing away, but wait, because on our homework, if you just give me answers with nothing else to work with, that looks a lot like a kid who copied the key. So could you at least show me your augmented matrix on your paper for your homework and also here on your notes? So your augmented matrix, be careful because you got to watch the order of your coefficients. This first guy is negative 4, negative 1, negative 1, and negative 11. What about the next line? Careful on that one. Okay, so it starts with 1x, there's 0y, negative 1z, and then 2 is the solution. So you have to keep the same order, x, y, z, solution. So the next one, the third one is 0x, 2y, 4z, and 0. So go ahead and get this guy typed into matrix A, or wherever. Technically you can put it wherever. And then you're going to command your calculator to do RREF of matrix A, or wherever you put this one. And I'm going to write down what my calculator showed me. I think this is one of those cases where they just give you a straight ordered triple. Now, if you don't get the same solution matrix like I did, that probably means one of us has something typed in wrong. And it's probably you this time, because I've verified this answer a few times. But now that I say that, I probably wrote something wrong. Okay, so we're going to want to write our answer as an ordered triple. Yep, 3, -2, and 1. I don't know why I'm switching orders on myself. Colors, rather. It's blue. Any troubles with the typing? Number 3 asks us to first write this as an augmented matrix. So this one doesn't really have any like weird skipping coefficients. That's nice. So on your augmented matrix, you guys start typing this into your calculator. Watch your signs, watch your typing. Some of us learned the hard way that typing wrong is going to cost us. I want you to carefully get everything typed in. Please, everybody, practice this. I don't hear enough typing to make me happy. I need you to perform RREF on this matrix. I think we got a weird one here. So right away, because of the line of all zeros at the bottom, I can tell we're going to have one of those infinitely many solutions ones where this is the harder one out of the 3. So we got to do a little bit of work. So we're going to take the first row and we're going to write it as algebra. So translate that first row for me. What does that really say? Uh-huh. Yep. Good. How about the middle row? Mm-hmm. Good. And then the last row, because it's all zeros, that's what creates this this dependent system that we're coming up with. This also tells me that I'm just going to let z equal z when I get to that ordered triple, which is right now. So let z be z. It's like the math version of you do you. All right, so x. I don't have a singular x, but I can come up with a recipe for x. Go ahead, Adam. What'd you get? Love it. So we rearranged this by adding the z over and got z minus 6. That's a way we can find x. And then how about for y? Mm-hmm. And z is z. So what we could do at this point, my teacher could say, give me like 3 solutions that work. So you pick your 3 favorite numbers and you plug them in to the ordered triple formulas one at a time. So like if 7 is my favorite number, I plug it in and I get 1, 0, 7. Boom, there's one solution for that system. 72 is your favorite number? Okay, you go ahead and plug that one. All right, let's take a look at number 4. I know you guys are sick of typing, so let me tell you what happens when you get this entered on your calculator as an augmented matrix. Nope, you don't get that. All right, this is your augmented matrix. Oh my gosh. Help if I could read. All right, there we go. After I perform the magic RREF, which I don't really do anything but type, my calculator comes out to, I'm not even going to write down the first 2 rows. The last row comes out to this, 0, 0, 0, 1. What does this tell you? This is a no solution. At no point in math will 0 of something equal a 1. I know, Daniel, quite the challenge for you. With a linear statement with coefficients, 0 cannot equal 1. So if that's the case, you're done. You write no solution, you walk away. You literally cannot find a solution. I know, another challenge I'm posing to you. Let's look at the next question. So earlier today when we did that system of equations by hand, and I was like, this might be the last time you guys choose to solve them by hand for a while, because matrices are just so much fun. This particular question, this is a 3-variable system we're going to come up with, and at no point do I want to do this one by hand, so we're most definitely going to use our new friend, the Augmented Matrix, to solve this. So, key to the question, the answer itself, what you're looking for, is at the bottom of it. It says, determine the number of each item built last week. So in this particular question, we are manufacturing tables, chairs, and stools. So X, Y, and Z sound like good choices to live in matrix land. What would you like X to represent? So what about the tables? Number of tables would work, yep. And this is where you do get a little bit of freedom. You can technically use any variables you want. You can call them whatever you want. If you don't like X, Y, and Z, that's fine. But when you set up your matrix, you just got to watch your order. Huh? You could draw little pictures if you wanted to. What do you want Y to represent? Number of chairs. Works for me. How about Z? Oh, that would not be a good choice. Number of stools. Alright, so now the fun comes up. You got to create your system. And this being real life, of course it's not going to be in matrix-friendly form. So once we create the system, then we have to rearrange it for an augmented matrix. But we'll get to that when we get to that. Alright, let's start with the first clue, which is probably the easiest question, a statement development. It says, a total of 275 things were built. So if you were to add up all of them, it should equal 275. So X plus Y plus Z equals 275. By the way, the fact that we have 3 unknowns means that we need 3 equations. Okay, that's a little math hint for you. Okay, next statement says the number of chairs built was, now was is a form of is, so it's an equal sign. So the number of chairs would be Y is 4 times the number of tables and stools. So if you take the number of tables and stools and you add them up and you multiply them by 4. I don't know why I put my 4 at the end, but I did. That's how many chairs you have. And then the last clue, that's the money statement. So it says, total of 42,125. A chair is 150, a table's 200, and a stool's 75. So I already lost track of what I just said. Number of table. Okay, so tables, 200, and then times X. A chair is 150, Y. I feel like I'm messing up the order. All right, and then 75 for the stool. And it equals 42,125. So we all know we want to use a matrix. The problem is, I like the way the blue equation and the black equation look. I do not like the way the green equation looks. So first thing I might do is rewrite this as y equals 4x plus 4z. And I still don't like the way that equation looks, because it's not in the same order as everybody else. I need it to go x, y, z solution. So after a little rearranging, keep x and z where they're at, subtract the y over. So 4x minus y plus 4z. And then there's 0 left over on the other side of the equation. So this is the form of that equation I'm going to use for my augmented matrix. All right, here we go. 111,275. This green guy, once we rearranged it, it became 4, negative 1, 4, and a 0. And then the bottom equation, got to write smaller, 200, 150, 75, and 42,125. All right, y'all get that entered into your calculator. I need everybody to participate on this one, please. Get that entered into matrix A.
Or the number of each item.
It's the value of x, y, and z. Yep. So after we perform RREF on this baby, I'm told you guys get some nice answers. You get 40, and 220, and 15. Which, you know, if you show up to your boss and you hand him this matrix, he's going to think you're a psychopath. So you're going to tell your boss what? We built 40 tables, 220 chairs, and 15 stools.
We sold that.
Well, I think it's what they built. They're a manufacturer. I don't know if they sold them or not.
Well, it came up with the final number.
It says the value of the items, not the selling price or anything. It's not the same, Daniel. You could build whatever you want, but they may not buy it. All right. So now that we know we can solve systems with matrices, and this goes all the way back to your little baby 2x2s or 2x3s, if it doesn't say otherwise, you are welcome to solve them with matrices. Here's the catch, though. I need to see your augmented matrix on your homework and on your test, okay? So give me a little insight as to what you did. So write your augmented matrix that you started with, make a little note that you did RREF, and then write your solution and interpret it. Speaking of things that we could do on our homework, the rest of your homework, you got a book assignment, page 372. There's like 4 questions. It's real short. And I did post the PDF of it. The other thing that you are assigned is worksheet 9. I believe I already told you this, but we are no longer making you do 9A. We crossed that off the homework check last week. But you are asked to do a couple questions off of worksheet 9B. So 9B are applications just like this chair and stool question that we just did. You guys are not doing 9A for homework, no. Maybe one day we'll look at a couple of those so I can show you how we could have used them. They're not bad. Who doesn't love a nice unnecessary system of equations? Yes, what's your question? Is there a question? Oh. On 9B, you are doing 2 and 4. So you're assigned 2 and 4. And for funsies, maybe let's start setting up 2. So the question might be a good place to start. It says, write a system to determine the number of coins. Y'all know how coins work? What do we have here? Nickels, dimes, and quarters.
M, D, and Q.
Oh, no, I'm going X, Y, and Z. I'm going to be lame today. What do you want X to represent? Number of nickels? All right. And then Y, I'm guessing you'll go with number of dimes. I like it. You're going in order of the question. And then Z would be number of quarters. And this was, open to interpretation. If Daniel wanted to use, N's and D's and Q's, he sure could have. What? Sorry. Now let's set up 3 equations. Okay, Tina has 31 nickels, dimes, and quarters. So they're not 31 nickels, but altogether it's 31. So that's supposed to be the easy equation for us. The number of nickels and dimes and quarters is to total 31. Now careful on this next one. This one takes some interpretation. She has 5 more nickels than the total number of dimes and quarters. So 5 more nickels, so the number of nickels.
Okay, so it's Y plus Z. What in the world?
Okay, let's start here. Number of dimes and quarters. What would that look like?
Y plus Z.
Y plus Z, okay. Can we do that? I'm asking, can we do that?
No.
Okay, tell me why, Daniel.
Because that's saying that if you take the number of nickels and add 5 to it, it has to be X minus 5.
Very good. Whew. All right. Oh, wait. Now you've convinced me, but now I don't believe you.
Thanks.
Because there are questions where you have to do this. Let's stop for a minute. Hold on. This is a good moment. I kind of used your N that I should... You know what? I should have done N's and Q's and D's. I'm very sorry. Okay. Back for a moment. Let's pretend she has... Let's just make up a number, guys. Dimes and quarters. How many dimes and quarters does she have?
She has.
Just pretend. Okay. Pretend she has 54. So she has 5 more nickels. It would be like, oh my gosh, why am I? Hold on.
No,
Time out. Time out. Okay. All right, so we're back.
X minus. No, why?
All right. So in order for the number of dimes and quarters to equal the number of nickels, there's a few ways that we could interpret this. So Daniel was suggesting, because he's right, where he said it's 5 more nickels than that. So if you were to add 5 to this, that would equal the number of nickels. The other way we could write that equation is just y plus z is x and then minus 5. So this is a really difficult concept for kids to balance out the equations, because the way we're taught to like translate equations is kind of counterintuitive of what's happening in this problem. So she has 5 more nickels than the total number, which means in order to make them equate, we have to actually take away those 5 nickels from that side of the balance of the scale. All right, so that is a really challenging question. We'll come back to some other examples of that in the next couple. But now we need to set up our third statement, which says total value. So remember, nickels are 5 cents, so 0.05x. Dimes would be 10 cents. You don't need the 0. And then quarters would be 25 cents. And it gives you a total of $3.25. So this needs to get entered into a matrix. Unfortunately, this green equation that we've been messing with so much isn't even in the right form. So if I was to rewrite this in the right matrix form, how about we just subtract the x over? So negative x, thank you, plus y plus z equals negative 5. This is the style that we're going to use for our matrix. So our augmented matrix that we're going to be entering into our calculator uses these 3 coefficients for the coefficient matrix. So sorry, that was a mess. We'll come back to that idea of balancing the equations a little better when we're setting up our systems.